To begin our review, we will summarize our journey through the fundamental MBSE concepts. We began with a consideration of the nature of systems. There we saw that systems are collections or constructs of different elements that together produce results not possible for the elements alone. This quality goes beyond a mere sum of the elemental results, and through the action of emergence, the system becomes more than the simple sum of its elements. We learned that systems cannot, by their very nature, be broken apart without destroying the system results. The act of breaking apart the system tears its relationships and destroys the results. Next, we looked at the results of emergence and saw what it means to engineer the system to produce the results that are desired. The results that will fulfill the requirements that move stakeholders and customers to request the creation and/or modification of the system of interest. We considered the role and value of models in projecting the results of a system design, and recognize that models are the only way we can communicate or think about our designs. The issue is whether the model is one retained in the mind of each designer, and therefore not necessarily consistent or complete, or a model instantiated in a tool where it can be seen in the same way by everyone involved in the project. From there, we talked about the purpose and characteristics of a systems engineering model, and saw that it portrays the system construct and elements in full relationship, allowing the design team to accurately assess its results and their fitness for satisfying the requirements. The important topic of complexity was our focus in session 4. We saw that complexity comes in two flavors, physical and adaptive, with physical complexity being the more deterministic of the two. Managing complexity is the central task for MBSE, where the model tracks the complexity and our candidate solutions for it. We also considered the pitfalls of MBSE's growing mythology. Confusion over the differences between logical and performance models, the tendency to regard views or collections of views as models, and linguistic oversimplifications all hold the potential for derailing the full power of MBSE. Having seen the role and the power of MBSE and considered the potential sources of misconceptions, we turned to its fundamental concepts. We learned the importance of taking and maintaining the system's view. We explored the reasons for beginning our projects at a high level of abstraction, and we learned of the 3 systems and 4 domains in the system lifecycle as they relate to MBSE. We then examined the layered approach that allows us to move the system design from a high level of abstraction to a practical measure of specificity by increasing the granularity of our model. We met the example problem, one that's been around for centuries. We saw how the constituency influences the commission of the team and the boundaries of the system to be developed. We explored the issues around boundaries and set the boundary for our problem. Next, we tackled requirements. We talked about the constituents, stakeholders, and customers, and discussed the process of gathering and analyzing their needs into testable requirements for the design. The requirements led us to behavior, the functions that actually satisfy the requirements. We saw how we use control constructs to build the individual functions into a logical architecture that we can simulate. We showed how the behavior can be developed as threads through the system. With the behavior developed, we went about the task of allocating the functions to the individual components of our new system. This established the relationship between the logical and physical architectures, tying the components to the requirements through the system behavior, thereby creating bidirectional traceability. With these design activities complete, the system was fully developed. Beginning with requirements gathered from our constituencies and elicited from use cases, we designed system behavior to satisfy the requirements. The behavior received and generated items which became the inputs and outputs of the process steps. The behavior was allocated to a physical architecture which passed the items from step to step while performing the functional behaviors. All this was verified through the system traceability and validated against the constituents' needs. We concluded our discussions with an examination of several design issues, including the ways and means of communicating our progress against our commission. So we have come a long way, and now we will attempt to summarize and wrap context around our journey. We hope that you have found this exercise valuable and that you have enjoyed the process. We will now close out our time together with some observations regarding systems engineering and the model-based approach. We have seen that our approach to MBSE is a layered journey. We begin high, at a high level of abstraction and a correspondingly low level of detail or granularity. This promotes innovation and offers us the maximum flexibility and range of design choices. We then move through the layers, lowering the abstraction and increasing the granularity until we reach a level of detail sufficient to provide a workable specification. As we move along this path, we develop an increasingly detailed picture of our solution built on this framework. Requirements elicited from stakeholders and customers using vehicles like use cases and user stories become the basis of functions. The functions, fed by items representing inputs, outputs, and triggers, are allocated to components, which are connected to links that carry the items. All of this is represented in a systems model, which is a limited representation of the system's solution. The systems engineering model becomes a cohesive, unambiguous representation of the system. It is the system specification and the visualizations that are derived from it. The foundation of the systems model is the logical or functional architecture. The fundamental design activities enable us to iterate the layers of systems engineering while structuring the system behavior to assure operational capacity. As they are needed, the design team adds resources and/or related behavior, as well as error detection and recovery behavior. At each point in the process, the team evaluates the design and performs required trade studies. Finally, they finish validation requirements and test plans, assuring complete design traceability. So what can we expect to gain from using model-based systems engineering? MBSE yields significant benefits to the design process. It provides enhanced communications by promoting a shared understanding of the design through rich representations. Our model visible to all, which promotes a common understanding on which to base our dialogue. MBSE offers reduced development risks through the early identification of requirements issues and a faster requirement cycle. Risk is further reduced by improved cost estimates. The MBSE process surfaces these all along rather than leaving their existence hidden to be discovered at the end of the design effort. In addition, an early and ongoing requirements validation and design verification contribute to overall risk reduction, as does the discipline basis for decision making which runs throughout the design process. MBSE offers improved solution quality. It does this through an enhanced system design integrity, the improved specification of allocated requirements to hardware and software, and fewer errors during integration and test. All of these lead to a more rigorous traceability from need through solution. Using MBSE offers increased productivity. The impact of requirements changes is exposed to analysis, allowing a more rapid analysis of those and other design changes. The reuse of existing models to support design technology evolution and the auto-generation of work products both free valuable engineering time from repetitious clerical tasking. In short, through MBSE, engineers are freed to be engineers. MBSE provides a structure to capture and communicate all aspects of the system. Its increased scope, made possible through the integration of the domains and their representation, allows the extensions of the representations and audiences to enhance a broad understanding of the solutions offered by the design. We have enjoyed preparing and presenting these sessions for you. We hope that you have found them useful. By no means is this a comprehensive treatment of model-based systems engineering. We have designed it to be a discussion of foundational principles. Hopefully it has stimulated you to think about our discipline and how you will practice it going forward. We welcome your comments and look forward to meeting you in the future. I have included my personal contact data here for you, and I invite your questions and any requests for help that you might have. Thank you for your time and attention.